Alright, we're taking the light bar apart tonight, and I'm going to start swapping out the stock LEDs for niches. This should be really boring. So I'm going to be doing the preliminary taking apart, and then the separation of the actual individual boards. I'll reflow those off screen and have some new ones for everybody else to look at when I'm done. So here we go. Let's find out exactly what size we need. No, that's too thick. Let's find some that fit. So the first step is to loosen these guys up. What these bolts do is tighten down that piece of Lexan in the front. Alright, now those are all loose. Loosen the end caps. I'm not going to film all this, of course, but very simple. Loosen end cap A. Yeah, do you really want to sit around and wait for this? I'm unscrewing those, and then I'm unscrewing that, and removing the end caps. We'll resume after that. Alright, here we are. All these bolts loosened up, including all the end caps. Nothing more. We'll take off this end cap. Get this end cap as loose as we can. Now you'll see there's a plexiglass cover that needs to be pulled out and set aside. Take care of that. You don't want to scratch that up or anything. There's a little rubber gasket that wants to go with that. There's another one on this side that hasn't come out, but we're going to pull that out anyway. All those screws loose. Now it's time to start disassembling the reflector screws. Once you have the reflector screws loose, go ahead and pick them out with a magnet. Makes it a lot easier. Sometimes you get a stubborn one. You work with it. Alright, so all those screws are removed. Take the reflectors out. There are two panels, 1 and 2. We'll have to take those apart. And here we are, beer nuts to nuts, with a set of screws to pull out the LED panel. No. Setting these aside over here. Oh, she's a bitch. There we go. Those. For those that don't understand, that's two screws. And she's gonna be a twat. Okay. I have tools for this. Oh, she's gonna be a jib. For those non-dyslexics, that's a bitch. Un momento. And after a little persuasion, final blows come loose. All right. So. We're clearly looking at 1 and 2 panels, both of which just slide right out, just like that. Aluminum housing, mediocre heat sinking, to say the least, but we'll improve on that in a few. More importantly, the dismantling of these panels. Wow, I'm looking at these two wires right here, and those are thin. Where's my micrometer? Get an accurate measurement here. One millimeter. Yeah. That I really don't think that's gonna cut it. At least not for what we're gonna do. That's gonna be a lot of reflowing. Are you sure you want to sit through all that? So continuing on with the 42 LED light bar Nichia upgrade. This current part of the video is sponsored by Carl Hicks. Motherfucker. You owe me a beer. So, I'm going to continue on, and first thing we're going to do is separate these two sections. Right here, big ugly solder joint. And we're going to replace that said solder joint with copper, some standard 14 gauge household copper wiring, solid. Get out of the way. Keep in mind these are copper boards, so you have to push some heat into them in order to get them to reflow a bit. I'm actually probably using the wrong. I am. Hold on one moment. Let's take this bit out. Replace it with that one, shall we? You got a little stubborn bits. Carry you. Yes, y'all are gonna frown at this one. There we go. She's out. New one in. For those that can't see, how about we zoom in on this? Very large, flat blade. And we're at 776, 780, 790. Give the temperature a bit to creep up. And 800. Alright. See how this does. I'm going to go across both of them. Both sides of the terminals. Here, we'll zoom in on that as well. As much as we can anyway. Yeah, we're zoomed in max, unfortunately, for this camera. First one. This is going to be a very boring video, by the way, just so everybody knows. Tell you what, we're going to reflow a little bit of fresh lead. Yes, lead. I said that horrible word, lead solder, onto this joint. Kind of help things along a little. Oh, that's much better. There we go. Now, at it, we'll take these little tin wires off. There we go. Those guys are clear. Not quite in focus here. Come on. There we go. Clean up our iron. Grab our solder sucker here. We're just going to work with this first pad set first. This is one segment. And those are nice and clean. Alright. Now comes the really fun part. Removal of the LEDs themselves. We're going to remove all the LEDs from both boards, and then we will install the new ones. Now, when you're doing an LED swap, what you really want to do is make sure that you don't cook the board, okay? These boards are, to some extent, temperature sensitive. You can't sit there and roast them and just keep leaving them hot. They'll eventually delam, which means the printed part of the board, where your copper traces and all your insulation is, will come off of the actual metal, and that's really bad. Now, to those that are wondering, I'm shooting this on a Canon DSLR, so I'm working with the best I can. I can't afford a video camera right now. I'm sorry. Someday I will get around to getting one. Alright, I have my bulldogs. For those that don't know what bulldogs are, they're a type of tweezer that when you squeeze them they open, and when you let go they clench shut. So that provides me with the ability to heat. Unfortunately, this is a lot shorter than I'd like. Yeah, I'm working on the video setup, guys. Don't worry about it. Someday I'll get everything squared away, and we'll just put it on top of that guy. How's that? Get it focused down on this thing's a bitch. Alright, so we're gonna remove these guys first. Just grab on. Let the heat do its job. As soon as the LED comes off, you want to move the heat. Don't sit there and keep roasting it. Don't do that hot plate method. That is just ridiculous. You're asking to delam a board, especially on a big guy like this. On the smaller ones, it's even faster, but at least you can pick up the whole board and move it along. On this, not so much. This will take some time. I do have to heat a large portion of the board in order to get the area of the LED to reflow temp. But that's why I have this particular heat gun, which has a very small tip. You can see it there. It's very, very, very small. I would say maybe 15 millimeters wide at the most. Maybe 3/8 of an inch, somewhere in that area. This is going to, again, be a very slow and boring video. And yes, I am saving all the old LEDs. Once the first LED comes off, you're going to want to move right down the line as quick as possible. That way you retain the heat that's already stored inside of the heatsink. I am applying very slight upward pull on the LED. Nothing linear, just straight up, very light pressure. Just waiting for the LED to pop off. Again, time consuming. But now what I'm doing is slightly touching the LED. As soon as it moves freely, I'll be picking it up. I just don't want to use the tweezers as a heat sink and suck the heat out of the board. There we go. Okay, so there's one. I'll go next. It's going to get more difficult to remove the LEDs once I get into this area because there's so much heat sinking on both sides. So that's something to keep in mind as well when you're refilling a large board like this. Ideally, you would do this with a preheater and with any luck a reflow oven if you have one. You can build one easily enough out of a toaster oven, that is. If you look closely, you can actually see little cathode marks on the board, little red dots. That's always a plus. Makes things a lot easier when you're going to reflow. You know which way you're going to put your LEDs. It's nice that some manufacturers put that on there. There's quite a few that don't, and that sucks. Oh, and something else I wanted to mention. When it comes down to YouTube videos, if you guys are going to put a thumbs down, that's fine. Go ahead and dislike or thumbs down a video if you want, but at least give a reason. Don't leave your YouTube video maker wondering why. I mean, all of us, we do the best we can. We work with what we have. If you disagree with what we're doing, that's fine. Say something. Don't just dislike and move on. If you don't say anything, we don't know. You know? Those things like, being pissed off at somebody for whatever they did and they have no clue. It just doesn't make sense. We had a little dome come off, and that's fine. We're going to salvage as many of these LEDs as we can, but we're not going to cry if we ruin a couple, which most likely you're going to do. It happens. This guy does not want to come loose. I don't know if that's because of the tweezers or what. We may, and I stress may, have to take the blowtorch method to these guys. I'm hoping not. I'd really prefer not to. Really hate using gas torches on electronics. It's so easy to go overboard. Fortunately, it's starting to look like we're going to have to. Alright, so be it. We'll bring the torch out. Now, as far as torches go, this is what I use. A little Ronsonol. Or Ronson. Keep it on a pretty low flame. Very, very small flame. And I always have grip of the LED before I even start this process. The last thing you want is to cook this board, because you're not replacing it easily or cheaply. I'm getting the hot cone right at the point of the LED. Push that heat into the solder joint. There we go. Hopefully the rest of these come off just as quick and easy. Another. Notice as soon as the LED comes off, I move down to the next one. You don't want to sustain that heat anywhere near the chip for long, if you can help it. Unfortunately, this process of removing the chips is going to require the same process to reapply the new chips, which sucks. Because this is not the best way to go about reflowing chips. But it is very effective. Wow, these guys are coming right off now. Finally got enough heat pushed into that heat sink. Got this big inductor right here that's sinking a lot of heat. But things seem to be going very smoothly. Which is always a plus. Again, as soon as the chip lets go, move your heat. Get it off that spot. And if you can, keep your heat moving around a little around the area. Don't concentrate it in one spot. Ooh, another de-dome. That's okay. Again, we'll save as many of these as we can, but I personally have no use for them. Somebody out there might. And I will happily sell them as previously flowed LEDs. Again, once you start to get towards the outside edge, things will get a little easier, a little faster. There we go. I'm going to continue the same process on this board. I'm not going to film all of that because obviously that's really boring. And I'll come back during the reflow of the new LEDs. Alright. Sadly enough, yeah, okay, fine. I'll continue on with this. Turn this torch down a bit here. Start pulling the rest of these guys. Squirrely little bastards. Apparently I need to clean my tweezers. Now, keep in mind when you're doing this kind of work, all these other little components and chips and things on here, they're desoldering as well. So, don't bump any of that stuff. All these little components are all surface mount, and while you're desoldering, yeah, you bump that, you bump that, you bump that, you bump these, you bump that, you bump any of this stuff, and yeah, you know what? You might fuck yourself. So, at least from an amateur's aspect, you don't want to, you know, try to reflow any of these major components while having the proper equipment. Especially these inductors, those guys can be really picky. You overheat these things and the enamel on the windings burns up and your inductor is toast. It just becomes an ecumenical pain in the ass. So don't do that. Alright. Give me a few and we'll get set up to clean the boards. Alright, so off camera I cleaned all the pads off, reflowed them with a little bit of lead solder, cleaned them, and then I fluxed them with a Kester 186 liquid flux. This is a rosin flux. You can see a little bit of yellow schmoo around the outside of each LED right now. The rosin flux is really sticky, so what it does is it helps hold all of these little chips in place while I go down the line and torch them all. But we have success. Of course, don't want to leave them on there like that too long because they're not on a heat sink. So next step is to do the little board here. and then solder them together and reassemble the whole project. And we should have a working Nichia plus 94 CRI big ugly bumper light. And I will be back with those details later. Alright, so we are beaded, which means I've cleaned off the pads and then applied a little beaded solder on them, just with a large blade tip. Just drag it across. Either I usually go across at an angle, sometimes I'll go straight across, but it'll trail off with the flux on there and clean up to a nice little bead on top. I do that in lieu of using a solder paste, which I don't care for personally. It's a little too finicky for my likes. Not to mention, if you want a decent paste, you got to keep it at the right temperature, and it only lasts so long. It's just a pain in the ass. Roll of solder will last years. I've already laid out my LEDs on the table here with their cathode marks in the right spot, so I could just place them right on up. Except that guy that I felt like throwing around, apparently. Sure, it's exciting, isn't it? That was sarcasm, in case you didn't get it. Now, when you're working with a rosin flux like this, it's a good idea to keep a bottle of alcohol nearby, because this stuff can get really, really sticky. And once in a while, it'll get up inside your tools, and you'll want to clean that out. And alcohol is the most effective means by which to do it. That is also fairly safe and inert for everything else involved. You wouldn't want to be cleaning any of this stuff with caustic, so. Come here, you little bastard. Another thing to keep handy when you're doing LED reflowing is a very simple toothpick. You use this for minor adjustments on the chip itself, and when it finally does reflow and settle, sometimes you have to tap them down a little bit just to make sure they make contact. Now, when I do this, this is going to be in two steps. The first step is just to heat the board. It's called preheating. It'll also help activate some of that flux. We will follow up right behind it with a torch. Small creme brulee torch like this, with a very fine flame on it, very small flame as well. You don't want to push too much heat into the board too quickly, or you'll delam it, or just burn it right up. But you also don't want it to be too cool, because if you sit there cooking on one spot for too long, it'll delam on you as well. Now, some of the LEDs, yes, look crooked at the moment. They will settle onto the pads when the solder flux wets. Or when the solder wets, I should say. They'll actually twist and settle right down on top of the pads. Capillary action and surface tension of the flux pulls them down, or the solder pulls them down. Put a little extra heat right in this area of the board because of that big inductor right there. You get back in your spot. Actually, see the flux bubbling on that guy right there. So zoom in if you see that or not. when the flux starts to bubble, sometimes it can move your chips around a little on you, which is, yes, annoying, but it's a fact of life. Always minor adjustments. Alright. And you can see I've got about blue cone about that far, 2 centimeters out of the nozzle. That's about all the heat you really want to put into these guys.
Oh my God, this is hopeless. We've been searching for hours. We're not going to be dead. No, you guys are really good. We got your home I need. You give up. Someone's got it, seems like. We're not having it soon. Excuse me, did you just say Sonia? That was my dog's name. Excuse me, did you just say Sonia? Yeah, dog. Oh, I thought you might have been talking about the super creepy woman who's always down there trying to live in her sex. Yeah, I thought you were talking about his dog. No, that's the Sonia we're looking for. Sonia, we can live there. Where exactly is this sex connection? I'm not sure, but that's because you need to know about the story. Apparently that chick's a complete psycho. Come on, guys, let's go. Man, I hope we don't catch me doing something freaky. It's still weirding out when I walk down there and ask her. Get it, man, oh my God! Does anybody not?
And sometimes they turn on you.
Hey, look, I want to apologize about the other night. It's time I have to make this choice. What are you talking about? Talking about love, right? Talking about tough decisions. Who's with me and how it's with you. It's time I have to take it. Dude, this is stupid. I'm not doing this. I need to cooperate or I feel like I'm going to be jaws. Hey, my voice isn't that high. It is the... All right, well, listen. Who will it be? Before you answer, you can all the times we've had. The time we have to beat me on the censorship. That winter we lived on the summer. And here's my favorite. A lifetime we can fill out with a future together. Yes! Hey, you done that when you're not up this wall? It's you and me forever, Rufus. This was Oscar, you take it too hard. This is it, everything you do. This is not just torture. I'll come to you. We'll come back when you got it. She'll be back soon. I think the guy with the ponytail and a facial tattoo with a princess. Let this happen. Hold that right there.
There, that should do it. Alright, I'll let that cool down for a bit and then we'll do some testing. Alright, after testing, we have full lumens. Yay. Next will be I will clean both PCBs and then it will be reassembly of the whole project and we will have a 42 LED light bar with high CRI. Hello again, finishing up the last bit of our 42 LED light bar project. All the LEDs have been swapped out. You can see here, these are the stock leads that bridged these two connections. I am beefing them up with some solid core house 14 gauge wire. Set those on. I did come across a fatal flaw when I initially disassembled this. You can see no heatsink paste, no heatsink paste, no heatsink paste, no heatsink paste. Little bit of dabs of it here and there. None of it was really pressed down very well. And the reason for that is
First off, they were cheap and only used 3 screws to hold the whole board down. But then the reflectors themselves had posts here that held them off. So what I did is I ground those down so they're flush completely here. And then I've also got some gaskets. They're going to go around all the LEDs. And that way there's equal pressure pushing down over every die across the whole panel to hold it down to the heatsink, along with some ceramic dew. We will be back when that is completed. Alright, everything's wired up. Let's go for a little test run right quick. I'm just using a 9-volt battery just to get the LEDs to light. Don't want to run them full power. They seem to be chooching right along. Cool deal. Alright, she's all back assembled. And here we go. I think that works. And the glow dots. On to the next project.